Hello, you're welcome to today's lesson. This time around, we want to show that the integral of 1 over x squared minus a squared is equal to 1 over 2a ln x minus a over x plus a plus c. Now, to resolve this question, the first thing we do is to resolve what we have here into a form that we can understand. That is, rewrite the integral of 1 over x squared minus a squared with respect to x to the form 1 over x squared minus a squared. Now, take note that x squared minus a squared is a difference of two squares because we have the square of one entity minus the square of another entity. So we can rewrite it in the form 1 over x minus a times x plus a. Now, this brings our attention to the fact that to resolve this, we ought to use the integration by partial fraction. We therefore have to resolve this into partial fraction. So let's move along. So 1 over x minus a times x plus a is equal to s, which is any quantity or any variable can be used for such purpose. S, I just use s, so s over x minus a plus b over x plus a. Now, the next thing we do is to multiply through by the LCM, which is x minus a times x plus a. So multiplying by this side will eliminate the denominator. We're left with 1. This time around, we come here, x minus a will be eliminated. We're left with x plus a. When we come to this side, x minus a will be eliminated. We will left x plus a will be eliminated, and we left with x minus a. The next thing we do, take note that we are left with 1 is equals to s times x plus a plus b times x minus a. We can decide to put x to be equal to a. Remember, at this level, we can decide to expand, but we want to use this approach, that is trying to eliminate one of these variables and deal with one before we come and take the other, right? So in doing so, we put x to be equal to a. That is, wherever we see x, we put a. So remember, there is x here, there's also x here. So putting x, a for x in this sense, and then also putting a for x here, right? So we realize that when we put the a here, a minus a will give us 0. 0 times b will eliminate the b. We'll be left with that of 2a and then the s. So 2sa equal to 1. We are looking for s, we therefore divide both sides by 2a, and we are left with 1 over 2a to be equal to s. Now, next step, we also want to eliminate the s and then deal with the b. In that case, we put x to be equal to negative a. Putting x to be equal to negative a, we will have s times negative a plus b negative a minus b. In that case, the s will be eliminated because negative a plus a will be 0 times the s to be 0. Now, at this end, we have negative a minus a giving us negative 2a, and that times the b will be negative 2ba, right? Remember, we are looking for b. Therefore, we have to divide both sides by negative 2a, and when that happens, b will be left with to be 1 over 2a. Now, that means that wherever we see s, we can input 1 over 2a. Wherever we see b, we can input 1 over 2a. And if you remember the first instance, the Where s is located, we put 1 over 2a, and where b was located, we put 1 over 2a. Therefore, we then rewrite it in this form, like the original form. At this end, we can begin the proper integration. Now, to do the integration, we can do it separately because these are individual terms, autonomous independent terms. We can therefore integrate this end and also integrate this end. That's what we are doing here. So the integral of 1 over 2a times x minus a dx minus the integral of 1 over 2a times x plus a dx. Now take also note that there is also a common number, which is 1 over 2a, 1 over 2a. It is better we factorize that out, and so 1 over 2a comes outside. We are left with the integral of 1 over x minus a dx minus the integral of 1 over x plus a. Now, taking our mind back to logarithmic integration. Now, when we have a certain case like 1 over x, what we do, or 1 over a certain quantity or a certain variable, what we do is that we use this form of integration that result to lim x. So if we have 1 on top, we have lim the denominator, right? So in that case, the integral of 1 over x minus a will result to ln x minus a, because the x minus a was the denominator. Then the integral of 1 over x plus a will result to ln x plus a, because x plus a was the denominator. Now remember, the minus sign is still at play here. Now at this end, this and this is logarithm. So we bring our mind back to the laws of logarithm, which says that having the same basis, if two quantities are being subtracted, we can write it in quotient form. So log x to the base y minus log q to the base y can be written in the form log x over q to the base y. Applying that, we realize that 1 over 2a is still at play. We can therefore write ln x minus a over x plus a plus c. That's a constant of integration anyway. So because we are dealing with indefinite integral, now at this end, we can therefore say that the integral of 1 over x squared minus a squared dx is equal to 1 over 2a ln x minus a over x plus a plus c as required. Thank you so much for watching. I believe the video was helpful.